Well, good morning, good evening, good afternoon to everyone, wherever you may be, somewhere in our world. Thanks so much for joining us live here today for the one and only Serverless Office Hours. We are streaming live on the AWS Twitch channel, so welcome if you're joining us from there, and also YouTube Serverless Land, and also via LinkedIn Live. Well, today, do you want to develop and test your AWS applications locally to reduce development time and increase product velocity? Well, today we have the stream for you. My name's Julian Wood. I'm a developer advocate for Serverless at AWS, and I have Waldemar Hummer, who is the co-founder and CTO of LocalStack. Waldemar, welcome to Serverless Office Hours. How did you land up doing so many cool things in the cloud with LocalStack?
Yeah, first of all, thanks so much for having me. It's great to be here, Julian. I'm glad we bumped into each other recently at the AWS Summit in London, so it's great to have the opportunity. Yeah, I don't know. I guess I'm just looking back at quite some history of working in the cloud and with the cloud, starting back in 2016 or so when I was working for a company called Atlassian. We had a bunch of AWS usage, and then sort of this was the initial sort of the birth of LocalStack, the first lines of code, and then kind of it was growing over the years. And very happy to share some of the updates here today with the community.
Cool, excellent. Well, obviously, Waldemar will be talking, doing lots of demos and talking a lot of things about all things local testing and development. But yeah, just looking back over the past world of serverless at AWS, the previous stream, it was all about events and messages with Confluent. So all things to do with Kafka. And so that was on our Serverless Land YouTube channel. And we had Joseph from Confluent, and Mithin from AWS taking through us just all the different integration possibilities. Yeah, super useful stuff. Kafka, high scale, high throughput, and using a serverless approach to consume those messages is just hand in glove, I thought. So that was super good. In terms of what's new in the world of AWS Serverless, well, if you're a front-end developer, AWS Amplify Gen 2 is now generally available. Whole bunch of cool stuff they've thrown into that. Some of the cool things I like is CDK is just built into it. So Cloud Development Kit, you're writing your front ends maybe in TypeScript. CDK support is just there. It's all just part of the bundle. And yeah, lots of other important big and small things as part of that. So have a look and see how you can utilize Amplify Gen 2. If using DynamoDB, quite useful, you can now configure a maximum throughput for on-demand tables. So no build shock, no performance shock, or messing up your access patterns. So that could be super useful for you. And if you're using shared storage, well, EFS could be your friend, and some maximum per client throughput to 1.5 gigs. So, and also actually, I may as well talk about the fourth one, DynamoDB as well, for AWS FIS, which is Fault Injection Simulator. So you can actually pause global table replication. I know we're going to be talking about chaos engineering today in the stream today. So yeah, cool to see DynamoDB doing that as well. On the sort of recent compute blogs, Ben Freiberg's got an interesting one about using the test date API. IPA sounds like a beer. I've got certainly getting to that time of the day, obviously, in step functions. So this is a whole new API which you can use to test individual steps within the step functions workflow. And he's got a really good blog post how you can do that in the console locally, and yeah, just expands how that test API can use. It is AWS Summit season at the moment. The next summit is Berlin Summit on the 15th and 16th of May. A couple of other summits are being planned for the later on this year. It's free to attend, lots of workshops, lots of breakout sessions, thousands and thousands of people with good, deep technical information. So yeah, if a summit is near you, I suggest going to have a look. Go to AWS. Go to an AWS partnering for EDA Day London. This is next week on May the 14th. It's in CodeNode, right next to Liverpool Street Station. I'll be there. A whole bunch of our team is going to be there. If you're going to be delving into event-driven architectures, deep technical talks, and also some great talks about making EDA successful in your business, and how serverless can sort of take you to that next level. So yeah, I think there are only a handful of tickets left, so jump in before they all go. But yeah, going to be a super, super good day, and I look forward to seeing you over there. Just before we get back to what we're talking about, thanks Joseph for joining us via LinkedIn Live. Love using the step test state in step functions. It's going to be one of those days where I'm tripping over my words. So yeah, that's great. And as you can see, Joseph is asking questions live. So please send us your questions, send us your comments. We'd love to hear from you, where you're from. Like good friend of the show, Daniel Abib. Thanks from YouTube. Hello, Daniel from Brazil. But yeah, send us your questions and your comments. So today, as we mentioned, we are talking about developing and testing locally. I know this is super important to a lot of developers. LocalStack can help. Waldemar, tell us about LocalStack.
Absolutely, yeah. So basically, do you want me to take over the screen share or just?
Let's.
Perfect. All right, thank you.
We also have Felipe. Thank you, Felipe, joining us via YouTube from Chile. Cool. So far, South America is getting. And we have also got Andy Mihalik from Connecticut, USA. So yeah, our American friends are helping us out today.
Very cool. Awesome to the global audience here, and it's really great to see some of the updates that you shared, which also I think tie nicely to the presentation today. Yeah, it's a pleasure to be here again. Thanks for having me, and happy to share some optimism about LocalStack. Maybe just to briefly share, some milestones in our journey. I think I already mentioned that LocalStack started in around 2016 timeframe as an open source project initially, where we sort of started like bootstrapping this community project, which is available on GitHub, which became quite popular over the years. And then sort of for the last 3 years approximately, we actually also started building a team around LocalStack, right? So we have a growing team. We're actually now a company. And in the meantime, over the last couple of years, we've released a couple of major releases. We've also been at the reInvent conference last November, had a booth there. So it was an awesome experience for us to just have a conversation with everybody on the expo floor. So yeah, really very much enjoyed getting all the feedback from the folks in the community. And recently released our 3.4 release 2 weeks ago approximately. So that is just some data points in terms of our journey so far. And just really what is LocalStack, right? So we are essentially at its core a local cloud development platform, as kind of the name implies. And it basically consists of multiple parts, but basically the 2 main ones are the core emulator, and this is probably what most folks may be familiar with, maybe have heard about, which is really a high fidelity AWS cloud emulator, right? Which has something like 90 plus services at this point that we basically run on your local machine in a Docker container. And then we have our SaaS platform, which provides additional features that basically built on top of the emulator to provide support across the SDLC, across the lifecycle. Basically, LocalStack is an easy on-ramp into AWS, right? So really, it helps teams getting started locally with pretty low setup effort, and certainly maybe not built for all types of workloads, but it definitely for serverless kind of workloads, we see a lot of adoption, just getting started quickly and then flip the switch whenever you're ready to go to the cloud any time. It enables these fast local development cycles, right? Quickly iterating on your logic like a Lambda or ECS. We'll see that in the demo today. And then also easily integrates with your IAC framework like Terraform, CDK, and the big ones. One thing that we like to say and emphasize is that LocalStack is something that complements a staging test environment. It's not a replacement for that. It's really sort of adding maybe one layer between your local and sort of before you actually run the first test in the cloud. But it really complements the overall end-to-end story with testing on AWS. And yeah, I also added this logo in here because we're also on the AWS Marketplace, just a little marketing here. Okay, yes, in terms of the 10,000 feet view of the solution itself. So imagine your application is this blue box here, right? And you're building some app, like a serverless app, for example, with Lambdas, DynamoDBs, tables, and so on. And as it's moving from the different stages, like from the local development machine throughout CI/CD, and then all the way to production or pre-production stages, we basically try and allow you to really shift left by enabling this testing very early in the process. And again, like really starting from your local machine, the very first lines of code. And then in addition, this is kind of illustrated here on the right-hand side. We'll also see that in the demo, we're focusing on some advanced team collaboration features, for example, where we have a feature called Cloud Pods, where you can store the state of an instance, of LocalStack instance, and very easily share it with your team members and recreate the exact same state on 2 different machines. And that has some quite nice application use cases as well. So that is kind of the very high-level story, if you will, of LocalStack. And so one thing that might be also interesting for the community is like how is it built, right? A lot of it is actually available in an open source project on GitHub. So you go to LocalStack on GitHub, fairly active community project. The community version covers some 40 plus core AWS services already, and then we have some advanced features in the pro version with additional services, and also these features like Cloud Pods that I briefly mentioned, KS engineering, and we'll see a bunch more of those in the demo today. From a very high-level point of view, so LocalStack is mostly written in Python, and you could think of it as a mini cloud operating system that runs in your container, right, on your local machine. So what we try to illustrate here is kind of some of the moving parts, and so we have an entry point, port 4566, which is kind of the gateway that exposes the services to clients. And again, this is all running just on your local Docker installation. And then we have some dispatching logic to forward these requests to different service implementations, right? And there's things like Lambda, obviously, CloudFormation, Kinesis, and many others. And sometimes these services would spin up new containers, for example, right? So Lambda is running in a separate container, for example, and others. So very kind of high-level overview of the architecture here. And the goal is really to have a lightweight system that is easy to use and also cross-platform compatible. And Docker gives us quite a nice abstraction there.
Thanks, Waldemar. So just also going back when you were talking previously about the reasons for LocalStack. Now, obviously, a lot of people developing in the cloud say they want to do things in the cloud as quickly as possible because it has everything in the cloud. Your services are there, your IAM permissions all set up, your resource policies, all that kind of thing. But developers do like to do things locally. So obviously, you've built up a whole company on doing the things locally. But how should developers think about what they develop in the cloud and what they do locally, and sort of, I suppose, the benefits and the trade-offs of both approaches?
Yeah, it's a great point. And so certainly what we're seeing, and we'll also cover this a bit later in the demos, with some what we refer to as basically maybe some hybrid modes, right? Where part of your stack is running locally and then part of your resources are remote. And I think we're probably also not the only ones in the space, but I think there's a few other providers who are maybe giving you the impression of a local sort of implementation. And I think AWS themselves also has some abilities to run your Lambdas locally, for example, in emulated mode. But I guess what LocalStack is different, kind of we bring like all your services essentially to the local machine, which obviously also has the implication that if you have like a huge deployment, right, hundreds of Lambda functions, that at some point your local machine will not scale anymore, right? So what we see also is a certain sometimes refactoring or re-architecting of repositories and code to make like smaller testable units, right? Maybe microservices that have a certain well-defined functionality with some queues, some databases, and so on, and then testing those individually before you actually hit the integration point. So we often speak also about the inner and the outer dev loop, right? And I think we really focused a lot on the sort of this inner dev loop of these frequent cycles of changes.
Okay,
that makes sense. Cool, awesome. Yeah, obviously there's so many. Had some great conversations also with, for example, Jan Kuh, who you might be knowing, like Serverless Hero, and he's got a lot of. He had a great talk actually at the summit around different testing strategies and methodologies, and it's usually not binary, right? There's always different trade-offs and mechanisms.
Yeah, so I think that was an interesting thing that actually Jan brought out, is that some people think you need to test everything in the cloud, some people think you need to test everything locally, but there's you do it all actually, because there's a lot of local testing that you're going to do, and particularly I think early on in your life cycle, you've got a Lambda function API gateway, and you want to, I'm just looking at the screen here, say mocking Kinesis, for example. You've got Kinesis. You'd all be wasting time for slow deploys and updating all these kind of things. So to be able to mock those endpoints, and some things you can't mock. If it's running in the cloud, to sort of simulate if you're being throttled by DynamoDB, for example, or to simulate that region for Lambda's gone down, for example. It very rarely happens, but yeah, these kind of things are pretty much impossible to test against in the cloud. So yeah, using things locally makes all kind of sense. And then on the other side of the equation, as you said earlier, you're not going to run your full end-to-end test suite before just flipping the switch into production when everything's running locally, because it's emulating. So I think it's a bit of everything.
Yeah, 100%. I think that's the key takeaway for sure. Yeah, cool. Yeah, so I guess, maybe just one more point on, so we have a pretty broad ecosystem of different integrations. So given that we're sort of working on the API emulation level, a lot of these tools are essentially, working out of the box in a sense, right? So you can bring your own ISC tools, for example, like a Terraform or CDK, different CI/CD systems, application development frameworks, and so on. So test containers, for example, is quite popular in the Java space, and they've promoted the use of the LocalStack container quite massively. So yeah, that's a lot of things, and we're constantly also adding more integrations here to make sure we meet the developers where they are and really what they need in their environment. Right. So I guess we can, dive right into some demos. I have a couple of short demos prepared, and I like to, keep these things really interactive. And also feel free to chime in anytime if you have any feedbacks or questions from the audience as well. So kind of to just get started with some basic use case, right? So first of all, let's just work with LocalStack and run some Lambda functions, and you work with some S3 bucket notifications. So what we have here is a small sample application that we can run and deploy locally, basically consisting of an S3 bucket where we're going to store a bunch of log files, basically just JSON logs with some content. We're then going to have S3 bucket notifications configured. So every new object basically triggers a Lambda, and then we do some analysis on these logs and trigger alerts in case there are certain values in these log files, like a high CPU threshold we received or something like that. And then we can receive these alerts also from the SQS queue. So I'll just switch over to my terminal here, and so part of the demos will be a bit sort of terminal heavy in that sense. I hope it's you can read the text on the screen.
Yeah, hopefully people on small phones will be able to see, but if zooming in anymore is going to be a little bit missing out on the stuff. So yeah. Hopefully
exactly. We'll try to zoom in as much as we can. It makes sense. Okay, cool. So let me go. I have a little cheat sheet here in my IDE, which I'm going to use to run through the demos. So the first one we want to look at is this sample trigger lamp, right? I'm just going to go to this directory here. And basically what we see, this particular sample is implemented as a Terraform script. So we'll take a look at the main TF file here. So this is something that a lot of the audience will be familiar with. So we define our AWS bucket here. We define our SQS queue with the queue policy, the actual Lambda function that's going to do the log filtering. We're going to take a look at that in just a second. Then some IAM roles for the Lambda itself, right? This is kind of the policy that's attached. The bucket notification, right? So whenever S3 object created is triggered, then we call the Lambda function. And then in addition, just some additional IAM permissions, basically. So what we're going to do is just go ahead and use our, and maybe even before we do that, let's just do some very basic interactions with LocalStack now that it's actually up and running. We have a small command line wrapper. It's called AWS Local, which you can use to just interact with LocalStack, right? So we can run S3ls, we can create a bucket here, and just fairly basic interactions with with the container, and we actually see the API calls as they're coming through here. I've got the debug logs enabled, so that's why it's pretty verbose here in the output. Okay, so this is kind of the basic interaction with the container, and now let's use our TF local command line. So that's a wrapper around Terraform. The only thing it basically does is to set the endpoints, and then we run and apply, and basically under the covers, this is now running Terraform. And we're just typing yes, and it basically now starts the deployment loop of this particular sample that we just showed before, and it's going to create our the queue, our bucket notification, the bucket itself, the permission, and everything that's defined in here. So we're just going to let that run for a second.
This is then running everything against that local endpoint. So you've configured Terraform to talk to the local endpoint, and so there's nothing happening in the cloud. You've just got LocalStack responding.
Exactly. Yeah, correct. Exactly. So this TF local script makes sure that basically there's no outbound interaction. It's all deploying against the LocalStack instance. Yeah, exactly. So yeah, so this is now done. Let's take a quick look at what the Lambda function is actually doing. So it's written in Python in this case. We have our handler here with the event and the context. So that's something that folks will be familiar with. Then basically we're just looping through all the records and do these checks if the CPU is higher than a certain threshold. Which will send out some SQS alerts and just some basic functionality. I don't think we need to go into too much detail here, but I would like to point out this print statement here, and we're actually going to change it in just a second to see how we can make modifications to the actual handler logic in the Lambda. So what we'll do next is to actually trigger this Lambda. Let me look at my run script here. So we have a command that's basically just doing an S3 copy of one of these sample log files into the S3 bucket that was created before. And as you can already see in the output down below here is actually running the Lambda function, right? So to do a Docker PS here in this terminal, it's showing a new container that was just spun up. One thing you'll notice is actually using the official AWS runtime images, right? And we are now seeing the output here, our hello world, and then also our alerts that get basically forwarded to SQS, right? So that is the logic in here in the Lambda function.
So that wasn't just, you're uploading the file to S3, and then behind the scenes, it also did the Lambda trigger. So it's not just, upload to S3, and then, you run your Lambda function manually and need to know where to pull from S3. The sort of magical Lambda trigger is all happening behind the scenes as well.
That is right, yeah. And we keep adding more of these inter-service integrations, I would say, be it an S3 bucket notification or, Event Bridge, for example, has all sorts of integrations. And so, yeah, fully, we're also, actually emulating the interactions between the services. And then, yeah, so the other cool thing is, so this Lambda is configured for what we call hot reloading. So we actually can make changes to this handler file now. And I'm just going to type serverless land here, or the serverless office hours. Office, can't type anymore. I'm just going to save the file, right? Just hit Control S, and then just do another invocation here. And again, it's uploading this file to S3. I'm going to trigger another invocation of the Lambda. And it's actually already done here, so we now can see the updated output here in the logs. So this is kind of the feedback cycles that we like to enable with this, what we call hot reloading. Obviously, the alternative to that would be just to create the zip file and then upload that again to the S3 bucket. Maybe just some of you may be wondering, so how does it actually work? So what's the secret sauce for this hot reloading? If you take a closer look at our Lambda definition here, you'll notice that it has, as the S3 bucket, we define hot reload, and as the S3 key, it actually points to our working directory /Lambda. So this is a bit of a trick that we apply. Hot reload is just a virtual bucket that LocalStack interprets as, okay, I have to mount the code into the container locally, and then basically just picks up any change from the local file system as you make changes. The alternative would be to use the file name here, which is kind of the way you would do it against real AWS, right? You just upload the zip file. But this is the hot reloading. Oops. Yeah, so this was a walkthrough, just some basic first interactions with LocalStack and just a serverless use case. And yeah, curious to maybe just going to pause here and see if you have any feedbacks or questions, anyone from the audience.
I think that's fantastic. I'm surprised how quick that was, even with the Lambda function. I've sort of seen local things happening, but the actual to see the S3 event notification and uploading a file to a pretend S3 bucket and then having that trigger a Lambda function does look super cool.
Yeah, exactly. So that's and one of the interesting things is also worth mentioning that in the Lambda, so we're also using things like an SQS client. Yeah. Actually, this one is still using a custom configuration, but in fact, with some recent changes in the SDKs, this wouldn't even be required anymore. So you could just literally define your proto clients as they are without having to specify the endpoint URL here. So basically, you can just bring your production code and then run it in LocalStack itself, which is also kind of nice.
Okay, wow.
Okay, yeah, so that was that, I guess. Again,
well, we did have a question from Madrag. Thanks I know you spoke about this earlier, but maybe just to iterate, is this an open source tool or has a fee? And I know there were two components to that. Thanks, Madrag, for joining us via YouTube.
Yep, thanks for the question. So yeah, part of the of LocalStack is like free and open source. So actually, let me quickly go to our GitHub repo. That's maybe a nice pointer here. Go to LocalStack/LocalStack. You'll see the public repo. We're also very much sort of happy for any code contributions. So if you want to provide like samples or issues or even like pull requests, please feel free to contribute. Everything that's basically in this repository goes into the community image, which is available free and open source. And then we also have an advanced version. And some of the features that we're going to show today are based on the pro version. But what I've actually just shown right now, that is actually also part of the community. So you could run this exact same sample that we just ran with the community version.
Yeah, because you said there were 40 plus services that were emulated as part of the free community version, and then additional services.
Yeah, exactly.
For the pro version.
Right. Cool, awesome. Yeah, thanks for the question there. So I guess maybe taking one step further is just taking a quick look at state management, right? So by default, LocalStack is an ephemeral system in the sense that it, whenever you restart the container, you basically get a fresh state. it's basically, flushing out the state every time. That is sort of by design, because a lot of folks who are using it is just, have a throwaway environment, essentially. Spin it up, run some tests, and then tear it down again. But we also have ways to actually do persistence and persist the state of your instance and share it with team members as well. So there's two main ways how we are supporting a persistent state in LocalStack. One is the regular persistence. We also call it snapshot persistence, where basically, as you're interacting with LocalStack, you can configure a feature flag that says persistence equals 1, and then just stores everything to a persistent volume, right, as you're making API calls to LocalStack. The other option we have is what we call cloud pods, and this is really more a point in time sort of snapshot of your container, of the instance. So you would say, I want to store the state at this particular point in time. You get a cloud pod. Doesn't have anything to do with Kubernetes pods. It's really just a state mechanism, and then you can store that to either a file or to our remote, cloud pod storage. And there's different ways to actually store the states. Then you can load it back into the instance later on. So it's really like the equivalent to assume you can snapshot an AWS account, like everything that's in it, and then sort of recreate that somewhere else. And then we can just run a short demo. So basically, the way that this is exposed is with the LocalStack CLI. So there's basically these two main commands, save and load, for cloud pods, and we can just quickly demonstrate how that works in this live demo. So given that we already have some application deployed here, we can actually just use that state, and let's just create a cloud pod from that right away, right? So I'm going to use the LocalStack CLI here, and we have a sub command. It's called pod. And here we have the different commands, and the main ones are save to create a new cloud pod, and then load. And we're just going to say save test serverless office hours. And this is now basically packaging everything up in the container, creates the cloud pod. It creates the version 1, so we also have versioning support, so you can create like multiple versions over time. And then basically all these service states have been extracted and pushed to the platform storage now. And what we can do now is basically restart the stack, right? I'm just going to restart my container. And if we're now interacting with it again, as mentioned before, the state is ephemeral. So just do an ls here. We're not getting any buckets because everything has been cleaned out. But now we can run the reverse operation, right? We load that cloud pod back into the instance. You see that something's happening here in the instance down below here. And now if we do another ls here, we actually see that the buckets are restored from before. We can see our Lambda list functions, for example. We can see our functions. So basically, we just recreated the exact same state that we had before from the application on the local machine. And that has some interesting use cases. One is obviously just like collaboration, right? So just being able to share your state, like, look, I'm working on something. Can we take a look at it? And the other interesting case is for example, assume you have something like a CI/CD pipeline, right? And something's breaking, something's failing. You can actually, snapshot the entire state, pull that to your local machine, and then just do some debugging. So that is another interesting use case there. So maybe it's a good opportunity now to look at our web application for just a second. So this is our kind of the entry portal into a lot of the functionality. It's app.localstack.cloud. And what you see here on the left-hand side is a couple of different functionalities and features that we expose to the user. One I want to briefly look at is our resource browser. This is something that might look somewhat familiar to some folks, right? It's a bit of a very simplified version of the AWS console, if you will, right? Just basically being able to browse your local resources in this user interface. So we can see our buckets here, for example, the one we just created before. Can actually go in there and look at the files. We can check out the Lambda function itself that we invoked before, just some basic information. And I think we can also look at the logs themselves. So we just saw here the invocation and then this updated hello world here. So this is basically just pulling the logs from the local container. So it's important to mention that any interaction from this browser is actually just talking to localhost. So there's no outbound connection in that sense. So again, like fairly simplistic if you compare it obviously to the AWS console, but being able to browse some of the state here. And Yeah, and the other thing we also have exposed here in the UI is cloud pods. So at this point, it's mostly just listing the pods that are defined in the organization. So this is our test organization that we use internally. And if we just look at the one we just created, serverless office hours, so that's the pod, that's the size of it. And now basically from here, we can also look at the versions and the files that have been, the state that has been created in here. So if we were to create more versions, they will actually show up in this timeline here, and you can go back and so on. All right, so this is a short overview of some of the UI functionality. We'll get back to the UI as we progress with the demos. But this was really the main the gist of Cloud Pods, I would say. There's also some alternative storage backends because, as you can imagine, not everybody's comfortable pushing some of their state into managed service. So you can also use, for example, you can actually point this as an S3 bucket. So if you own an S3 bucket in your organization, you can push a pod also to your own on-premise storage, basically, or S3 bucket. All right. Cool. I guess I'll just keep plowing ahead with the.
Yeah, well, you could do as many demos as you want. I mean, in fact, the requests coming in via the questions are, it's all about different kind of demos. So will there be any demo for AppSec? Thanks, Manish, for joining us. And Daniel says, yeah, a good demo maybe. Step functions, calling Lambda, even API gateway. So yeah, any demo is always appreciated. Don Vito Code said, wow, nice. So that was, I think, looking at the cloud pods. So that was that was cool. And then, Rishi Roy, thanks for joining us via YouTube. So is the use case for LocalStack mostly to test integrations between various serverless services locally? And is there a way to test LocalStack in a hybrid way with few services running in the cloud?
That is spot on. So that is the second part of that question is something we were going to get to in towards the end of the presentation. We have this hybrid mode. The first part, it's definitely testing integration between serverless services. So we're definitely quite strong on anything like Lambda and ECS containers. EC2 workloads are something that are a bit more tricky to emulate locally because running VMs. Although in fact we just recently launched a new feature where you can actually spin up like a hypervisor and like actual VMs for EC2.
Oh, wow.
So some great work from our team there. But for the most part, it's really serverless workloads and integrations. And I guess with this increasing focus on event-based logic in the cloud, right? A lot of it is you have all these events flowing through, and you have like this indeterministic order of events. So I think it really becomes important to test, first of all, frequently, and also have a way to replicate certain scenarios, right? So if coming back to the CI example before, if your test is failing and maybe it depends on the order of messages in the queue, then you can actually really sort of take that on your local and inspect what was the contents of the queue, basically, and which messages, what order were the messages executed. So I guess it's really a lot about these, serverless event-based use cases and workloads that are really.
I mean, just talking about those event integrations, because obviously when you're running it in AWS, maybe you have something like EventBridge and EventBridge pipes, and it is going to pull something from, say, a DynamoDB stream. The EventBridge pipe is going to do maybe some transformation. It will maybe then send it to SQS, for example. In a way, there's no code. It's all just running in AWS. And if, for example, your filter pattern is incorrect or that kind of thing, I appreciate it's not necessarily that easy to find out where in AWS something has tripped up. Maybe you've got a permission wrong to SQS, for example. Can you sort of do some troubleshooting through the LocalStack internals to see where a message was going and what was happening with it? Or is that what that debug log allows you to look for?
Yeah, it's actually really a great segue into the next section when we look at IAM and some of the debuggability around IAM. But yeah, so I think so there's a couple of ways. So the logs are a great reference for just seeing like in which order are certain events happening. The other part is really like literally setting breakpoints in your Lambda. So we have some setups where you can say, for example, I have my IDE and my Visual Studio Code to set a breakpoint here. And then I guess the third one is really Cloud Pods, where you can just snapshot the state and then later on inspect what was actually going on in that particular instance of this queue. But we'll get to that in a second. One thing I wanted to briefly also point out before, because the question was asked, which if you can show some samples. I may not have an AppSync sample ready right now, but I would love to provide a point in our docs. We have this section here in the developer hub called applications, and you can actually browse through all these samples and, for example, select AppSync here. And if you go to this link, it actually opens up a repo some of these sample apps are actually taken from some of the AWS samples directly, and we just showcase how you can run them directly on LocalStack. So if you're interested, I think it's a great reference to explore different sample apps there.
Oh, great, thanks.
Okay, cool. Yeah, so I guess coming back to really your point also, so IAM is an interesting feature for us. We, some early versions of LocalStack basically did not have any IAM capabilities, right? So it was all a permit all system in a sense. But we kind of figured out that, especially once you make the transition from local to AWS, it's good to have some kind of local validation already for IAM, right? To make it a bit less, a bit more frictionless experience. So we've put a bunch of innovations around IAM into the product, and team members have done a fantastic job here, providing this both in the core emulate, but also in the UI. We'll just show that in a second. And really, I guess we've just observed some pain points around IAM. When crafting up these policies can be a bit cumbersome, error-prone. Policies should ideally be less privilege. And again, there's lots of tooling around IAM. We're not the only ones doing that, but I think we have some interesting value-add features that I would like to briefly showcase. One of them is called the IAM policy stream, which really is able to generate policies based on observed behavior that you run against the emulator. And as one of the nice kind of canonical examples that we often use for IAM is, assume you have an SNS topic connected to an SQS queue, right? So that is obviously a pretty common pattern in AWS. And it requires permissions for the topic to be able to talk to the queue, right? And if those permissions are missing, then the integration fails, and sometimes it fails silently, right? So you basically put a message in the topic and it never arrives at the queue. And if that's the case, then it's quite likely that IAM is the culprit. And there's several other examples of this, but we've invested some time and effort to actually make this more visible to the user with a feature that we call IAM, explainable IAM, to actually make this more explicit in the tool. So what I'll do here is for this sample, and I'll just go back to my cheat sheet here. So we all looked at Cloud Pods, IAM policy stream. So just go in here. So for this particular sample, we're actually going to use a feature flag that's called enable IAM equals 1. So this is required to actually enable the internal IAM enforcement engine, right? So it actually observes all the requests that are coming in, and then we can now deploy this small application sample that we had before, right? So I'm just going to take a look at test sh. This is basically has a set of commands that we can now run to deploy these resources. So I'm just going to create a topic here that's named test topic. We'll create a queue that's called test queue. And then next we'll actually subscribe the queue to the topic, right? So this is just a subscribe call itself here. And the subscription has now been created. So now you would assume, okay, everything is looking good and it's up and running properly. And what we do now is we actually try to publish a message to the, I think I have a escaping issue here. We now try to run a message in the demo gods are hopefully with me today. Let's see what's happening here. I was expecting an error ready to pop up now. Let me try to receive that message. So I'm not sure if my demo gods are with me here right now. Okay, we can actually, so then let me just try and see if that flag was actually coming through. And did I have a typo here? No, I think it's not enable, it's enforce IAM. My apologies. Enforce IAM equals 1. Okay, so just like the wrong feature flag. So we're just going to do that again. I'll create a topic. I'll create the queue, and then we're just going to do another subscribe. Just stepping through the same commands here. Subscribe, and then the publish, right? And now if all goes well, yeah, okay. So now this is the error that I was hoping to see. So it's now basically telling us, okay, this user, or basically the SNS principal, is not allowed to run the send message operation on the queue, right? And again, this is sort of, again, it's kind of exposed here in the logs, but we also have something that you see in the UI, but it really gives you some additional insights really here in terms of what are the necessary permissions for a certain action, what has been explicitly denied, explicitly allowed, and implicitly denied, right? So really giving some additional insights. The same would also work, for example, if you're executing a Lambda function on a certain execution role and it's trying to access some other resource, so you actually get this exposed here in the terminal.
Yeah, I mean, that's a permissions area you would never see unless you had some Cloudflare logging on or something like that, because it's between it's an inter-service process or inter-service message, and yeah, you just wouldn't know, things wouldn't have arrived.
Yeah.
Wow, that's great.
Yeah,
that is awesome.
Yeah, so this is.
I suppose that's two use cases. That is also finding when you have an issue, but I know it can also you can use that to obviously generate permissions as well, because you can find out what permissions are required.
Exactly, 100%. And this is sort of to close the loop on this demo here. So if I go to the IAM policy stream, so this is some UI functionality that we've created here, which actually now gives you a summary of the requests that were coming through. And actually the required resource-based policies, for example, right? So in order to do send message, we need to have this particular policy defined on the resource. And if I now go quickly back to my scenario here, we've actually created this already. So I can update the IAM policy now to grant this SQS send message. So this is actually setting the policy. Yeah. You can take a look at this attributes JSON in just a second. And again, I think I'm missing something's messed up with my terminal here. So like this. So now we've basically updated the attributes. Let's take a quick look at what this looks like. So if I go to my services, this is the attributes JSON that we've just enabled as the queue policy. It's pretty hard to read because it's just this stringified JSON, but basically it's the exact same thing that we just saw in the output before. It's just allowing on this principle, on the SNS, under the condition that this aren't equals, we're basically just allowing the send message action, right? And now if I go back and do another publish here on this topic, it should go through, fingers crossed. And it is actually going through, and you're then able to consume it from the other side.
Wow, very slick, yeah.
Yeah, so this is kind of the IAM, and again, we keep sort of adding some functionality because it's something that seems to be quite well received.
Yeah, Daniel asks, can we see the roles and policies in the LocalStack console?
So in this particular, I think we have a bunch of outputs in the console. Oh, are you maybe referring to the web UI? I'm assuming maybe the question goes
possibly.
towards
Daniel, let us know here.
So we do have an IAM section here, which has also policies. That now has a bunch of different policies. I think it also might have the AWS predefined ones in here. So I'm not sure if we can actually filter. But yeah, so as you can see here, there's actually ways to get the policy information from the web UI directly, albeit relatively simplistic UI features again. Okay. Yeah, so this is kind of the IAM topic we wanted to cover, and again, switching gears to I think one or two more I'd like to cover, and then see what else comes up in terms of Q&A. So the other interesting point, and I'd love to see the update you had on FIS there on the first slide, which is really almost like a perfect match to what I'd like to show here. So basically, what we define as chaos engineering, and obviously this is a term that's been in the industry for some time, is to build robust systems, resilient systems based on injecting errors and latencies into the API layer and then seeing how your application reacts to that, and making sure that you actually have retries in place or things like fallback logic or asynchronous dead letter queues and whatnot. And one example here, a canonical example that we often show is, let's assume we have some Lambda functions, let's say 2 Lambdas here, to create products and get products that are exposed via an API gateway, and they both basically read and write from a DynamoDB table. And one of the classic problems that can happen here is if you have provision capacity defined for this table under high load, it can start rejecting requests essentially, right? So basically, it's going to tell you, okay, I'm basically at capacity. You're not able to longer store any new items, for example. And then typically, what you would do is create some fallback logic in your Lambda handler to do some retries, and if it still fails after retries, you put that to a dead letter queue and have some asynchronous processing that eventually writes back to the table once it's back up again. And again, we'd like to, and the holy grail, quote unquote, here is really to simulate this errors conditions, right? So being able to really inject this error, and presumably this is also what the FIS implementation of AWS that you mentioned is doing. And we're following a similar mechanism here where you can actually simulate an outage of this DynamoDB table. Okay, so I'd like to quickly deploy this app and then just step through what this looks like. So what I'll do is restart LocalStack one more time. I'll remove the enforce IAM flag this time. And let me just get in my cheat sheet, this is my chaos engineering demo. By the way, again, kudos to our team for putting together all these awesome demos. I'm really mostly showcasing them on behalf of the entire team, and it's great to have all these samples up and running already. So basically, in this sample, what we'll do, let's take a look at this in my IDE here real quick. Replicator. I'm getting lost with all the different samples. Yeah. So in this case, we're gonna provision all the different resources with the command line. So this time we won't use Terraform or anything. It's just really using all these AWS local commands to create the DynamoDB table, create our Lambda functions for adding products, for getting the products, the REST API gateway for defining all the routes and methods. And the integrations as well, and then towards the end we have the topic and the queue. So basically everything that we saw in this architecture diagram before is just gonna be created now with this run script. And init resources it's called. And so this is now basically creating Lambda, get product, create REST API, the different methods, the deployment, the queues. And yep, that's it. So we're now done with.
That's quick as well. I mean, if you think that everything is happening locally, yeah, you're super quick to set up this mock stack.
Yeah, that's true. It's reasonably fast. Right. So then just making sure that I'm demoing this in the right way. So again, going back to my script here. Okay. So the next step is actually to run a curl request. So basically hitting this API gateway. So let's test the happy path now. So we are basically just gonna, everything's fine. There's no issue with the table. So we can just basically do the happy path. And I think I have a curl command in my history here, which we can use. This is just basically hitting a local execute API endpoint, which is the API gateway. With this subdomain here, this is a local endpoint, and just hitting the product API with some payload that just adds a product to our DynamoDB table, right? So I'll just add that, or just run the script, which is basically under the covers calling the API gateway. It has spun up a Lambda container. This time it's implemented in Java, actually, this particular function. And now the happy path has actually worked, right? So we're all good. Table is up and running, so that's nice. So now, actually, we can go to our web UI and take a quick look at the table. So if we go to DynamoDB, we should be able to see in our products table, if I go to the scan of the items, we see, okay, this product has been added, so that's all good, right? Nice.
Thanks, Rahul, for joining us via YouTube as well. Rahul's one of our cool people internally, and we also looking, seeing how we can improve many things at AWS as well to also make LocalStack even hopefully better and do lots of cool things. So thanks, Rahul, for joining us.
Thanks, Rahul. Yeah, great feedback. Okay, cool. So now I guess the next step will be really to go to our chaos engineering section here, and this is really some user interface configuration for enabling the chaos mode, right? And we have various different ways. For example, you can simulate an entire region outage. You can say US East 1 goes down as a very drastic example. But in this case, we're just going to take it more easy and say, okay, DynamoDB is starting to raise throttling errors or rate limiting errors, right? So we have this slider here with the percentage, and we can just say with 100% probability, basically we want to raise errors in DynamoDB. And this is now basically what we're gonna trial, so that the chaos mode has now been enabled. And if I try to run another curl request here, I'm just going to use a different ID for the product. The rest just stays the same. What we actually see is, first of all, we see that in the output here, it was starting to raise some errors. I think we have just too much output here. That's
I saw the 49
yeah, right.
message.
Yeah, but the thing is, like, it's now printing, okay, DynamoDB error occurred, message sent to the queue, right? So this is now, this is obviously the logic in the Lambda function itself. So we have in this Java, we have a handler that's actually catching the exception and puts it to the queue. Actually, maybe it's worthwhile just taking a quick look. So it's not, so you actually believe me that we have a proper Lambda here. So where's my experiment? So the Lambda functions here, source, main, Java, and the add product.java. This is the Lambda function we're using here. And it's using this put item request, and we just have a try catch here. And then it's just saying, sending it to the queue because something was wrong with the processing, basically. So we're hitting this try catch path here. And now basically what's happening in our architecture figure, this asynchronous Lambda tries, it keeps hitting DynamoDB and tries to add this item asynchronously, and it keeps failing because we still have chaos mode on. And we can now go back to normal, right? If I say I want to, reduce the error probability to 0 again, so everything is back to normal essentially. Then we will see probably one last invocation, which is successful, and now the product has been added to the table eventually. So if you go to our table items and do a quick refresh, how can I refresh here? I think I need to do a submit. Then we actually see the other item also coming through in the table here. So this is essentially, and again, we have some more, more drastic chaos examples where, again, if Lambda USE1 goes down, how does the application react to that? And that can help with things like a disaster recovery exercise or something where you actually like an actual region or availability zone goes down. Okay, was there any feedback in the chat? Any questions?
No, that's good. I think you've got another demo, so let's go through that, and then we can.
Yeah, awesome. Okay,
too.
Cool. Yeah, so I think the last one I want to briefly showcase is around what we call hybrid mode, and this is essentially it's something it's an experimental LocalStack extension, so it's something that is sort of a plugin for LocalStack. And what we mean by hybrid is basically, if part of your stack is running on the local machine and part of it is in the remote system, right? And this can be useful for larger deployments where maybe you're just working on a single microservice and you want to connect to the rest of the AWS application landscape. Maybe you have some DynamoDB tables or S3 buckets you want to connect to. So really just iterating on part of your logic locally, but still sort of accessing some remote resources. And we built this extension that is called Replicator, and it has two modes. One is what we call replicate mode, so you can point to an existing AWS account and copy essentially, or replicate the resource into your local instance. And the other one is called proxy mode, where it's more outbound, right? So we give you the impression of a local interaction. You're interacting with LocalStack, but behind the scenes is actually calling out to a real AWS account to contact a table or an S3 bucket or something like that. And we have this, shouldn't take too long. I have this set up here. What we'd like to showcase here is a simple demo where we basically have a Lambda function running on the local machine. We'll have an SQS queue that's actually, the SQS queue exists both on my local machine and in the AWS account, in a real account. And we have an event source mapping from the queue to the Lambda function, right? And basically what we're going to do is once we enable this AWS proxy, it will actually, we can add a message to the queue and it will trigger a local Lambda invocation, right? So this is kind of how you interact with AWS, and then it basically proxies the call to your local machine. And I'd like to briefly showcase what this looks like. So again, my cheat sheet here is this one, hybrid mode. So I'll go in here, also here, and what we'll do as the first thing is in my run script. Just to make sure that I'm actually using all the right, I think this is probably fine what we already have started. Well, let me restart the instance just in case. It's always good to start with a fresh state. And okay, we'll just step through these commands. So first we'll create the Lambda. It's the zip file. I mean, let's actually take a look at the Lambda itself. It's pretty simple. So in my replicator, I have this test Lambda. Is basically just an event that prints out the event. So nothing really much happening here. And so basically we're going to create the function now. Again, this is a local stack, creating the function as we did before. We are creating the SQS queue, right, locally. So that is now running on my local machine. And we're also going to create an event source mapping. Actually, before I do that, I'll actually switch over to the actual proxy. So the proxy is what we've implemented as a LocalStack extension. Extensions are basically plugins that we can install into LocalStack. There's a bunch of different plugins here, extensions, and one of them is called AWS Replicator. And I'll just go in here. I already installed this ahead of time. Actually, it's already in the instance, and it has a configuration UI, which I'll just briefly showcase. Basically, what you can do in this UI, you can configure some credentials. So we're actually going to be talking to real AWS, right? Just for a certain subset of the calls. And we defined that the proxy should forward any S3 requests to a certain bucket and any SQS requests to a certain queue to AWS, right? So I'm just going to save this configuration here, which basically brings up this AWS proxy behind the scenes. And once that's up and running, we can actually start interacting with it. And let me just quickly show you real quick. I've prepared a little S3 bucket. So here we're now in real AWS, right? So this is a bucket called LocalStack test replicator, and I have a file in here. And now that we have the proxy enabled, we can actually do an AWS local ls on this bucket name. And it should give us the so basically what's happening. It's connecting to LocalStack. LocalStack connects to the proxy, and that actually calls out to real AWS and gives you the result. And you can then do a copy command here, for example, and we can copy that to TMP, and we can then open the /tmp LocalStack wallpaper, which is just the file which is downloaded here. So that is the simple sort of S3 case. And now going back to our other example with the actual Lambda. So that is now the other trick. I think this is just done in a second. I'll just look at my run script again. So we've created the function. We now create the event source mapping. And now, since we have the proxy enabled, if all goes well, it should actually start polling the external SQS queue, right? And I'm switching here to the SQS view. I've also ahead of time created this test queue here, and we can now try and enter a message. So the message has been sent to the queue, and we can actually see. Let's do this as side-by-side comparison. So I'm adding a message to the queue here, and it's actually triggering a local Lambda function that processes the event that was coming through from the remote SQS.
So how is that proxying the event source mapping in AWS? That's clever, because it's obviously not doing it locally. It's got to be something in AWS as well that's doing the proxy.
So it's literally just basically since we just use a polling mechanism. So LocalStack just use the credentials to just poll for new messages and yeah.
So it's doing the event source mapping, what it does under the hood, which is a poll, but can run that locally.
Yeah, exactly. Cool. Cool. Yeah, I guess we're pretty much on time. So I'm not going to cover the sandboxes. I think we basically can close off here. But yeah, I think just a reflection. So LocalStack has come a very long way in the last couple of years. So I really encourage everybody who maybe hasn't used the tool in the last 1 or 2 years, give it another try. It's much more polished product today than it was in the past. It turned out that building a high-fidelity cloud emulator is incredibly hard, but it's feasible, a huge team and community effort. And I think we really see that it's a great on-ramp into the AWS cloud, and you can natively bring all your IC frameworks and so on. And we're exploring a bunch of use cases, and we'd definitely love to get your feedback as well. We have a blog post coming out soon that's called Building LocalStack with LocalStack, which will be interesting. We showcase how we use some of the tooling for building our own cloud platform. So that's coming out in the next week or so. So stay tuned. And yeah, I'm happy for any feedback, and please do get in touch.
Excellent. Well, we could have carried on for another hour. There's so many cool things to look at. I'm super impressed. Just before we do go, I did want to get Nicholas's question in. Does CDK work to provision resources in LocalStack? What's the recommended way to create resources? I think the question, because you showed that Terraform in the beginning, you're just pointing to the local resource, and CDK thinks it's deploying it in the cloud, but magic, it's local. Yeah,
exactly. So we also have a CDK local script that basically runs CDK under the hood, and it can 100%. So for CDK, it actually transpiles to CloudFormation, and we have a CloudFormation engine implementation in LocalStack, which makes it work.
Cool, excellent. Well, kudos to you and the team with all the work to emulate these kind of things. As you say, it's hard, but it's feasible. You've done a huge amount of work. So, Waldemar, thank you very much.
Thank you so much. Great feedback from everybody, and it's been great, Julian. Thanks for having me.
Cool. And yeah, same time, same place next week, 14th of May. We're actually going on a Gen AI little sojourn, but we're not building a chatbot because there are too many chatbots in Gen AI. So we're going to build a personalized Gen AI nutritional web app. I've seen this. This is fantastic. take photos of your fridge and it can suggest recipes, scan a barcode and it'll tell you the nutritional information. So Cornelia is going to be coming next week. This is going to be super good. It's actually going to be just after EDA day. So we're going to be able to show that as well. Thanks, Daniel, for joining us today. Glad you found it was useful. Thanks, Waldemar. Everybody, thanks really for joining us for Serverless Office Hours. Thanks for your questions and comments. Let us know how we're doing. Always love to hear where you're from. Waldemar, thank you very much. And
thanks,
everybody else,